Nearly every day we are bombarded with media stories of a coming apocalypse, the result of global warming caused by man's burning of fossil fuels that increase CO2 in the atmosphere. All of these forecasts of doom are based on the results of computer models that project substantial amounts of warming over the next 100 years. But should we fear what these computers are telling us? I have built computer models of dynamic systems and other complex processes for over 20 years, and I can tell you that it is extraordinarily easy to create computer models that spew out meaningless results. And the more complex the model, the easier it is to get such a mess. In this video, we will look at the results and key assumptions of climate models and test them against reality and recent history. What this exercise will tell us is, don't panic. Climate scientists have developed a useful shorthand for the relation between CO2 and warming called climate sensitivity. Climate sensitivity is defined as the amount of warming we might expect from a doubling of CO2 levels. The UN IPCC, in their last report, found that many climate models are using sensitivities in the 2.5 to 4.5 Celsius range. These relatively high sensitivities necessarily drive large forecasted temperature increases. But what is poorly communicated in the media is that these sensitivities are built in two steps. In the first step, scientists calculate the warming from CO2 alone, without any other effects. Most scientists believe this sensitivity is in the 0.8 to 1.2 range, as exemplified by this formula from the IPCC's third assessment. Okay, the math is a bit complex, so here it is in graphical form. I have set the function to have its zero value at 280 parts per million, what is thought to be the pre-industrial number. We see the function passing through today's value at about 385 and proceeding on to 560 parts per million, which is double 280. If you read the graph at 560, you can see the warming value is 1.2 C, which is what we mean when we say the climate sensitivity is 1.2. Recognize that this first step climate sensitivity of 1.2 does not get us to a catastrophe. It would imply a warming over the next century of less than 1 degree. The catastrophe comes instead from the second step. Complex feedbacks in the climate system are assumed to multiply this number by a factor of 3 or more, which is how higher sensitivities and forecasts are reached. This is the basic feedback formula, showing how feedback F can increase or decrease an initial temperature change dt. This formula implies 3 outcomes. If feedback F is negative, then an initial temperature increase is damped out and reduced. If it is a positive fraction, then the temperature increase is accelerated. If the feedback fraction is greater than 1, then the temperature runs away, the tipping point effect that people sometimes refer to. Let's look at an example using a bowl and a golf ball. Let's start with the bowl upright. When we apply a force to the golf ball, the shape of the bowl, gravity, and friction all work against the initial force to slow the golf ball and bring it back to its starting position. This is negative feedback, and 99% of the natural processes you can think of are ruled by negative feedback. Now we will flip the bowl upside down and again apply a very small force to the golf ball. This time gravity and the shape of the bowl tend to amplify the initial force. Even though I only lightly tap the ball, it ends up accelerating and rolling far away from its starting point. This is positive feedback, when forces at work tend to amplify or accelerate an initial input. Here, for example, is a natural process dominated by positive feedback. As you can see, positive feedback leads to instability and runaway processes, so it is rare to find long-term stable processes dominated by positive feedback. In fact, most scientists assume that when they meet an unknown but stable process, that it is dominated by negative feedback. Climate scientists, however, are an exception. Without a lot of good reason for doing so, climate scientists assume that our Earth's climate is dominated by positive feedback, such that 1.2 degrees of warming from CO2 alone is multiplied many-fold. Let's return to our graph of sensitivity. We can now think of our original CO2 sensitivity graph as being when F, or feedback, equals 0. But we can easily rescale the chart using our feedback formula for feedbacks as high as 0.6 or 0.8. Normally I would call these very, very large feedback numbers, but they are necessary assumptions to get sensitivities on the order of magnitude as those reported in the IPCC. So now we have several different forecasts. Which one is right? Well, remember the world has already marched partway across this chart, increasing CO2 to 385 parts per million. So we can see how well these different assumptions match history. For each feedback assumption, we can interpolate what temperature increase we should have experienced historically, having grown CO2 to 385 parts per million. Now let's compare this to history. This is what the surface temperature measurement record tells us for world temperatures over the last 125 years. We see a temperature increase of about 0.6 C. Now nobody's thermometer tells them how much of this 0.6 of a degree is from man's CO2 and how much is from other causes. The IPCC says that most of it is from man, others disagree. I will use the 0.6 number for now to avoid argument. Back to our sensitivity chart. You can see that 0.6 C is way below what we would have expected to see with higher feedback-driven forecasts, even if all the 0.6 degrees was from CO2. In fact, 0.6 degrees at 385 parts per million implies a sensitivity of 1.37, which is way below catastrophic levels or the levels used in making catastrophic predictions about the Earth's future. But there are a lot of reasons to believe that even 0.6 of a degree is high as an estimate of past man-made warming. Almost certainly some of this warming is from natural causes, as the intensity of the sun has increased over the last century. Further, evidence is mounting that the surface temperature measurement network is biased on the high side, as confirmed by satellite measurements. McIntyre and McKittrick recently demonstrated that as much as half of the measured surface temperature warming may be from urban biases around measurement points rather than global warming. Plugging a smaller number in for historic warming due to CO2 in our sensitivity chart yields a sensitivity of about 0.8 C, again well below catastrophic levels. Based on this analysis, it should not be surprising that the first IPCC forecast in 1990, which was predicated on a 2.5 climate sensitivity, quickly proved to be too high. Actual world temperatures have undershot these forecasts, tracking more on a 1 to 1.5 sensitivity than the 2.5 sensitivity in the forecast. Since these findings, climate scientists have refused to adopt a lower climate sensitivity. Instead, to make the forecast fit current temperature trends, they have posited a second man-made cooling effect. They have developed a hypothesis that various man-made pollutants, like sulfur dioxide aerosols and black carbon, tend to reflect sunlight and mask some of the expected warming. These aerosols are assumed to cool early years of the forecast, but then be eliminated in later years, allowing temperatures to catch up. This assumption yields a warming curve like this, flat in the early years where cooling is in effect, and very steep in the later years. This gives us a real problem in evaluating these forecasts. Is the current fairly gradual rate of historical temperature increases a result of high levels of cooling aerosols masking large amounts of positive feedback? Or is the historically slow rise in temperatures simply evidence that our climate is not dominated by positive feedback at all, and that temperature increases from CO2 can be expected to remain small? More bluntly, is this masking a real effect, or is it an arbitrary plug to save face for the computer modelers? From this analysis, we can see that in order to believe higher forecasts, you have to believe two things. One, that the world's climate is dominated by strong positive feedback, and two, that man-made aerosols are substantially cooling the Earth, masking half or more of the actual warming. Neither of these propositions are well supported by good science. We have already discussed feedback. Let's take a quick look at aerosol cooling. These aerosols, unlike CO2, are short-lived and local in effect, and only exist in any concentrations in small areas of the world, as shown in orange. This means that for total worldwide temperature increases to be masked by, say, 1 degree, temperature masking in the aerosol-affected areas must be on the order of 10 to 20 degrees, which is absurd. Further, if aerosols were masking temperature increases, we would expect the northern hemisphere, where most all these aerosols can be found, to show less warming than the southern hemisphere. But in fact, just the opposite is true, with the aerosol-free south warming far less than the north. So in conclusion, without feedback, CO2 at most only causes nuisance levels of warming. Only very large assumptions of positive feedback make CO2 warming forecasts catastrophic, and these are extremely hard to justify in a long-term stable process like climate, and the science of these feedback processes is extremely unsettled. In fact, our temperature history over the last 125 years does not seem to support these catastrophic levels of feedback. So in short, don't panic.